So this video, we're going to talk about lesson 5.1, which is about the coordinate grid. So you're going to need your new packet for this one. If you were not in class that day, make sure you get the packet before you start watching this video. The first thing I want you to do here is just to go ahead and copy down these first two definitions. The coordinate plane, we're talking about that as a plane, just a big flat surface divided into four quadrants by the two axes that we use for graphing points, lines, things like that. And then an ordered pair are those points on the graph. So we talk about an ordered pair as an x comma y in the parentheses, and that gives us a specific location on the graph. So pause this if you need to while you're writing this down, and then we'll keep moving here. Up next, we're going to talk about the different pieces of our graph. And so when we talk about the two axes that divide our graph, that's the x-axis and the y-axis. So if we start here, the one that goes horizontally from left to right, that is the x-axis. I'm going to label that. The one that goes vertically up and down, we call the y-axis. Those two give us our location. If I have an x coordinate and a y coordinate, that tells me a single location on the graph. Next up, we have our origin. Origin is the point 0, 0. So I'm just going to say origin 0, 0. That is the place that we start when we graph points. There are four quadrants on the graph, these four sections that the graph divides into. Traditionally, these would be numbered with Roman numerals. So Roman numeral 1, Roman numeral 2, Roman numeral for 3, and Roman numeral for 4. If you want, I think it would be a good idea to also just put the numbers 1, 2, 3, and 4. I'm fine with you just labeling them with the actual numbers instead of the Roman numerals. Number 5. Each of these different quadrants, since we're going a different direction on the x or the y, have their own pattern for the points. So if I know that both my x coordinate and y coordinate are positive, I know that I'm in the first quadrant. So I want you just to label in here, this is a positive, positive. I'm going positive in the x direction, positive in the y direction, I will end up in the first quadrant. If I go negative in the y direction, but positive in the x, so negative, positive, I will end up in quadrant 2. If I go negative in both directions, I will end up in quadrant 3. And if I go positive in the x and negative in the y, positive, negative, I will end up in quadrant 4. Finally, we want to label the ends of our axes with the infinity symbol. And so I'll just pick another color here. Oh, purple, why not? So on the positive end of our axis, we'll put infinity. On the negative end of our axis, we'll put negative infinity. Just as a reminder that these keep going forever. Just because this one stopped after 5, that arrow, that infinity symbol, means that it keeps going forever. Up here at the top of the y-axis, positive infinity. Down here at the bottom, negative infinity. Okay, if you need to write that down, go ahead and pause the video, and we'll move on. So the next one here is just a little bit of practice with ordered pairs. So on each of these, they want you to find the point. So there's point A, and then give its ordered pair. So this one I'm going 3 to the left. So that's a negative 3 in the x direction, and 4 up. So that's a 4 in the y direction. And then tell the quadrant that it's in. So this one is in quadrant 2. If it's on an axis, just go ahead and label it as x-axis or y-axis. I want you to go ahead and do B through F, and then pause the video, do B through F, and then come back and we'll check over those. Okay, so hopefully you tried those on your own. Point B is at the point 2, negative 3. That's in the fourth quadrant. Point C is at the coordinates 0, 2. That is on the y-axis. D is at the point 7, 1. That is the first quadrant. E is negative 4, negative 6. That is quadrant 3. And F is at the coordinates negative 5, 0, which is on the x-axis. From there, we're going to go ahead and talk about x and y intercepts. And what you notice here is on the graph, there was one point that was on the x-axis. That was point F. And it had the coordinates, as you could see, negative 5, 0. And we call that an x-intercept. That's not how you spell intercept. Intercept. There we go. And x-intercept, all that means is that it's a point that's on the x-axis. It is, if we're thinking about something more like a line, it is where the line crosses the x-axis. If I'm looking at the graph above, the point that's on the y-axis is C. We'll call that the y-intercept. And usually we'll be talking about these with a line or something crossing the y-axis, and that's where that word intercept comes from, crossing over that axis. Down here, this is exactly what I was just talking about, naming the x and y intercepts for each graph. The x-intercept is just where the line crosses the x-axis, so right there, that is the point 3, 0. The y-intercept is where it crosses the y-axis, and that is the point 0, 2. Over here, the x-intercept, 2, 0, and the y-intercept, where it crosses the y-axis, 0, negative 1. One thing I want you to notice here is that anytime we have a y-intercept, you'll notice that anytime we have an x-intercept, you'll notice that the y-coordinate is 0. If it is on the x-axis, that means we can't have gone up or down at all, so that y-coordinate has to be 0. Same thing happens with the y-intercept, just in reverse. Since we are on the y-axis, we can't have gone left or right at all. So the x-coordinate on the y-intercepts is 0 every single time. Okay, let's go ahead and flip over here and we'll talk about the last thing we got to do, which is relations. A relation in math is just a set of points. The reason we call it a relation is that it relates the x value with the y value. So when you see a point like 1, 2, that is just telling you that the point 1, the x value 1 goes with the y value 2. They're related to each other. And it's just giving you a set of relations for however many points there are. All of these ones we call discrete. I'm not actually sure that's not how you spell discrete. I have no idea how to spell discrete. It might be like that. I don't know. But anyway, discrete is when we have just a series of points. Like we could count the number of points. That's what we're going to be talking about today. Eventually, we'll talk about continuous, where we actually have infinitely many points. So if I have something like a line, there are infinitely many points on that line. But for today, we're just dealing with a set of points. So from the ordered pair to the table, all we have to do is take each point and copy its x and y value into the table. Each row of the table is a point. So see there's 6 points, 6 rows. So I'm just going to go ahead and copy them over like that. Next up is our mapping diagram. Now in our mapping diagram, the first box represents the x's, circle. The second circle represents the y's. The big thing here is that when I do a mapping diagram, I don't put duplicates in here. So the number -2 shows up twice in my x's. I'm not going to put it twice in here. I usually put these in order from smallest to biggest. So -2, -1, 0, 1, and 2. Same thing with my y's. I'm going to put these in order from smallest to biggest. There's 2 -1s. I'm not going to list 2 -1s. I'm just going to put it once. What actually shows my relation here is arrows. So if I look at this and I see -2 and -1 are paired up, I'm going to draw an arrow from the -2 in the x to the -1 in the y. -2x, -1y. I also see that -2 in the x is paired up with 0 in the y. So that one actually gets 2 arrows. And then I'll just keep going through these. -1 looks like it gets paired up with 2. 0 gets paired up with 1. We did -2 already. 1. 1 gets paired up with 2. And 2 gets paired up with -1. So we're back up at the top. And what you can see here is 2 of these numbers actually have 2 arrows going into them. They get paired up with 2 different x values. And that's okay in a relation. For now, however that works out, we just put those arrows in to show the relationship. Any more than about 6, 7 points, it's going to get pretty messy. That's okay. We're not going to use that for very much longer with a lot of points. the final thing here is just to graph these points. So if I have 6 points, my graph is just going to be those 6 points. 1, 2, negative 1, 2, 2, negative 1, negative 2, negative 1, 0, 1, negative 2, 0. It's just those 6 points for a discrete relation like this. Eventually, we'll talk about ones that are continuous, where I might have all of the points that follow along a line, for example. Okay, I want you to go ahead on these. Try this first one. So try the first one, then unpause the video and make sure you got it right. Then pause the video again, try the second one, unpause the video, and make sure you got it right. I'm just going to work through these. I want you to pause the video and actually try them yourself. You learn best by trying these. So I'm just going to go ahead and do this. You check on your own as you go. So I'm just putting my points into the table. For my mapping diagram, I'm going to list these numbers from smallest to biggest. So there's all my x's. Here's my y's, negative 4, negative 1, 0, 1, 2, and I'll just draw arrows. So 3 goes to 0, 0 goes to negative 1, 2 goes to 2, negative 4 goes to positive 1, and negative 3 goes to negative 4. And then I'll go ahead and put in my graph. So 3, 0, 0, negative 1, 2, 2, negative 4, negative 1, negative 3, sorry, not negative 1, negative 4, 1, up there, and negative 3, negative 4. So it looks like that. Pause the video again, try the second one, and when you're ready, play it. Okay, this last one here, I'm going to go ahead and put these in. What you'll notice here is there's all the x values are different numbers, negative 4, 0, 1, 2, and 4, where for the y values, I only have 1 and 3. So on this, the negative 4 goes to the 3, but all the rest of them are all pointing to the 1. They all get matched up with the 1. That's okay. For a relation, it doesn't matter. You might have noticed in this one that every single x value had its own unique partner in the y values. That is a pretty special relation. We actually have a name for that we'll talk about next week. So on this side, we don't have that. There are a lot of them paired up with 1s. I'm just going to go ahead and graph them. 0, 1, 1, 1, 2, 1, 4, 1, and negative 4, 3. So you can see a lot of those values have this, those x values have the same y value, and that's okay. Okay, so after this, we're going to be going ahead and doing our proficiency practice. It's on page 4 of your packet. There's a CFU on the Canvas page, and instead of a Delta Math, we're going to be completing page 5 of the packet today with a little bit of review from last trimester. Make sure you're doing that proficiency practice first, and since this Delta Math or this review page is review and not something extra or more challenging, I do expect that all of you get to that. You're going to get through this proficiency practice in CFU pretty quickly, so I do expect all of you to do that page. I will see you tomorrow.